Hello and welcome to Math with Mrs. Becker. Today in calculus, we are going to continue in section 3.1. The first part, we looked at something called the product rule. How do you find the derivative if you are multiplying two functions together? Well, what happens if you're taking two functions and you're dividing them? When that happens, we have to use something called the quotient rule, and that's what we will look at today. Okay, so the quotient rule means that you are trying to find the derivative of a quotient, meaning you have one function being divided by the other function. The main thing to remember or to know, the top function is f of x. Okay, so whatever's on the top, that's your f of x. Whatever's on the bottom, that's g of x. Now here is the quotient rule. The first chunk on the top, you take g of x, leave it the way it is. So you're taking the denominator. You're multiplying it by the derivative of f of x, which is the top. That's the first chunk on the top. Minus the second chunk. You leave the top function the same. You multiply it by the derivative of the bottom. Okay? Then from there, you can go ahead and subtract, combine any like terms, simplify the top. The denominator is going to be whatever the current denominator was, and you just go ahead and square it, okay? Make sure you are careful with the order of this formula because of the minus sign, because you're not adding. With the product rule, if you accidentally switch the order because you're adding, sometimes it ends up working out okay because of that commutative property of addition. Remember, it says you can add things in a different order. Well, this is a minus. There is no commutative property of subtraction. So you have to make sure you're very careful when you are following the quotient formula, okay? So the first thing I like to do, if I have x over 2x plus 3, okay? This is a function because it contains a variable. This is a function. F of x is always whatever's on the top. So our f of x is going to be x. G of x is always the denominator. So it's 2x plus 3. So now on the top, the first chunk, and again, I like to use brackets just to kind of separate everything. You keep g of x the same. So it's 2x plus 3. You multiply it by the derivative of f of x. Well, the derivative of x is a 1. Minus, now the second chunk, you keep f of x the same, which is x. You multiply it by the derivative of g of x, which in this case ends up just being a 2. So what I do is now, again, I'm only working on the top at this point. I can go ahead and simplify this. If I multiply by 1, it won't change anything. This is 2x plus 3 minus x times 2 is 2x. Now, when I simplify the top, positive 2x cancels a negative 2x, so the top is a 3. The bottom is whatever the original bottom was, 2x plus 3 quantity squared. There is your derivative. Okay, so that is the quotient rule. Let's look at another one. The top is always f of x, so f of x is 2x. The bottom is always g of x, so 2 minus 3x. If I am looking at the top first, I keep the bottom the same, so 2 minus 3x. You multiply it by the derivative of the top. The derivative of 2x is 2, minus the second piece on the top. You keep f of x the same, which is 2x. You multiply it by the derivative of the bottom. The derivative of 2 is 0. The derivative of negative 3x is negative 3. So now if I'm simplifying the top, the 2 can be distributed because it's 2 terms times 1 term. 2 times 2 is 4, minus 2 times 3x is 6x, minus 2x times a negative 3 is a negative 6x. So if I'm minusing a negative, remember that actually means that here I am adding 6x. Now check this out. Negative 6x, positive 6x cancels. On the top, all that I have left after I simplify is a 4. The bottom is whatever the bottom was, quantity squared. The bottom was g of x. So it's 2 minus 3x quantity squared. There is the derivative. Okay, let's look at another one. Again, step 1. F of x is the numerator when you are dividing, so it's x cubed. G of x is the denominator, x squared plus 1 all to the power of 4. So f of x and g of x. The top piece, the very first piece, you keep the bottom the same. So it's x squared plus 1 to the power of 4 times the derivative of f of x. That's 3x squared. Minus. Now the next piece, I keep f of x the same times the derivative of g of x. This is going to be the general power rule. Okay, so I would have 4. You bring the exponent up front. Keep x squared plus 1 the same. Reduce the exponent by 1 times the derivative of whatever's on the inside. The derivative of x squared is 2x. Okay, so these are the two pieces. I can go ahead and combine them. So this would be 3x squared outside of x squared plus 1 to the power of 4 minus. Now I can multiply these things together because they do not have exponents. So if I multiply the numbers, 4 times 2 is 8. This has 3 x's, this has 1x. So it would be x to the power of 4, and that's being multiplied by x squared plus 1 to the power of 3. That's all over, check this, x squared plus 1 to the power of 4 squared. Okay, so again, I did the first part. I kept the bottom the same, multiplied by the top, or multiplied by the derivative of the top. I just multiplied those. Okay, so I put the 3x squared out front. I could not distribute it because of this exponent. Minus. Now the next one, you kept the top the same, multiplied by the derivative of the bottom. Because I have an exponent on a binomial, this was general power. The exponent come out front. Keep the parentheses the same. Reduce the exponent by 1 times the derivative of the inside. I can combine x cubed, 4, and 2x. I can multiply them. None of them go with this exponent. So x cubed times 4 times 2x is 8x to the power of 4. That's being multiplied by x squared plus 1 to the power of 3. Okay, so there's the top. The bottom, you keep the bottom the way that it is, but you square it. Remember, if you have an exponent inside and outside, you multiply them. So right now, I would have 3x squared outside of x squared plus 1 to the power of 4 minus 8x to the power of 4 times x squared plus 1 to the power of 3. That's all over x squared plus 1 to the power of 8. Now, the only way that you can simplify is if you have the same thing in each piece on the top and on the bottom. And you guys, we totally do. Notice this. X squared plus 1, x squared plus 1, x squared plus 1. So I can simplify this. This piece has 4, this piece has 3, this piece has 8. So the least amount is 3. So I can cross off 3 of them. If I cross off 3 of them, that would cancel. Here I would only have 1. If I had 8 and I cross off 3, this is a 5. So all I'm doing now is simplifying. Okay, if I go back and I relook at the top, okay, this is gone. I divided it out because we had it in common and everything on the top as well as the bottom. So now that this is just 1x squared plus 1, I can go ahead and distribute. The reason I can now is because we got rid of the exponent by simplifying. So 3x squared times x squared is 3x to the power of 4. 3x squared times 1 is 3x squared minus, all I have left here is 8x to the power of 4. I can combine like terms. This has x to the power of 4. This has x to the power of 4. 3 minus 8 is negative 5x to the power of 4 plus 3x squared. That's all over. What I have left on the bottom is x squared plus 1 to the power of 5. That is your derivative. Okay, so again, just like with the product rule, the way to get more confident and more comfortable with the quotient rule is to practice. There are 8 questions in the textbook that I feel are very, very helpful and definitely worth your time. So go ahead and try some of these. When we have our Zoom call, I will go through some of those with you just to make sure that everything is making sense. I hope you guys enjoyed the quotient rule. I'll talk to you soon.